Alright, so moving on, let's see some attributes. Hopefully this gets a bit more exciting. Let's put something heavier. Amount of Marth should do it. Okay. So once you download the package, you're basically gonna get this Vexe folder. Except it's not gonna have UF action in it. So you're gonna get this DLLs, editor, and runtime. And in the DLLs folder, there's basically some editor extensions and editor helpers, and runtime extensions and runtime helpers, and then there's some third-party DLLs like FasterFlect and Part-of-Net, which is used for visualization, and FasterFlect I use heavily for faster reflection. So what you're mostly going to be interested in is go to runtime, go to examples, and for starters, let's open up the drawer scene. So this is the drawer scene, just showing off some of the attributes. So first off, we'll see this. Well, first you'll notice, the first thing you'll notice if you've ever used my previous show 'em all packages is that the categories look a bit different. They look a bit nicer. The header was big, and now it's a little bit small and smooth. Another addition, you'll notice that I brought the script field back, and you can also control the view of your categories right from here. So GUI box, splitter. I personally like GUI box and splitter, and remove line numbers, just like that. And here you can change the serializer. So you say protobuf, okay, binary formatter. Now the default serializer is binary formatter, and here you can view the serialization data. Now this is read only, and you should modify it. Shouldn't modify it. In fact, you can't modify it. So if you add, you can't. So this is just mainly for debugging purposes, and if something goes wrong, you'll see. You can look at these values and help you determine what's going on. So BetterVector, let's see, BetterVector example. Okay, let's let it reload. So basically, you get this BetterVector attribute, which when you annotate a vector to, come on. Okay, so you could annotate the vector 2 and 3 fields or properties, and what you get is this little foldout here that gives you some functionalities like randomizing, setting it to 1, normalizing it, and setting it to 0. You can also copy it and paste it, which is nice. So it's pretty basic, it's pretty simple, just BetterVector. Moving on, we have ShowType. Now, from previous show 'em all versions, I was using serialized type instead of type, but now I can serialize System.Type at will. So basically what I have here is an abstract class, tactic, strategy, and then a 3 children, so divide and conquer, fire at will, and hold fire, and each of them have a different implementation. And then in my better behavior, I have a private, notice I'm using save, like I mentioned before. You could use save or serialize field. So I have a serializable base polymorphic strategy, which is also hidden. And then I have a type reference annotated with ShowType, type of tactic strategy. And basically what that will do is that will give you a selection window with all the concrete types of the type that you pass in here. So excuse me, not selection window, but pop-up basically. So ShowType, we're doing ShowType tactic strategy. That will give me all the 3 children of tactic strategy, right? and then I can choose from them. Now notice there's also this unchanged. So basically this is a very useful attribute that you could use. So you could pass a method to call or set a field or property once this value changes. So when this value changes, I'm calling set strategy, and the method that you call requires you to have one argument of the same field type. So when this value changes, the new value gets passed to this set strategy, and I'm checking it to make sure the type is null, and I use this type. I create an instance of that type and set it to my strategy. Now notice I'm using this instance, which is an extension method available in my Vexe runtime extensions. This basically uses fast reflect to create an instance of your type. This is much faster than using activator create instance, so you should use that instead. So notice when I change it, I get a debug log. This is because we're logging the type. We're doing a log. And when I perform, say it says fire at will. If I run, just to make sure that the value serializes, still says fire at will, and if I invoke fire at will, great. Now notice this was actually a workaround for polymorphic serialization in my previous showmall versions. In the new API, you don't have to do this. You could just have you could just unhide this tactic strategy, and basically I will show you a selection window of which implementation you'd like to use. But having a serializable type and ShowType are also useful. It will have its usages, but not in this case. In this case, you could just use you could just do this, and like you'll see in the abstract example. But I just wanted to show you that type is serializable, and you could use ShowType to give you a pop-up of certain types that you want to use. Moving on, we have some constraints. Now this is basic stuff. So you have IP, which is a regular expression. You have max for float and int. You have clamp, string clamp to clamp the value of the string, to clamp the length of the string, and you have numeric clamp to clamp numeric values, and you have regular expressions. So in this case, this value must start with the string name colon. So let's see. So clamp to 10, so if I type more than 10, it goes back. If I type less than 10, oh, this is clamp between 5 and 10, yeah. So if I type less than 5, it goes back to the previously valid value. So if I typed in like more than 15, it would go back to 15. If I type less now, it would still go back to 15. If I type, say, 1, 2, 3, 4, 5, 6, and then type, say, two strings, it would go back to 6. So it would go back to the previous valid value. So clamps float between 1.5 and 10.75. Value must start with name. So if I start with something else, it would go back to the previous valid value. IP. So I had to do it like this. Can't go further than 100. Can't go below 1.5. Clamps between 3 and 10. Can't go below 0. Can't go further than. Now notice how exchangeably using fields and properties, just to emphasize the fact that attributes work the same on auto properties and fields. And you also notice that you can add comments and compose attributes. Now I'll talk a bit later on composition, but not now. I just want to go over the attributes. What is this? Requirements. Okay, so requirements are pretty cool. Basically, they allow you to have a very little configuration to do as possible. Basically, when you say, for example, when you say required from this, this means that this component is required from this game object, and if it's not assigned, you're gonna get a warning saying that saying that couldn't find component game object. So it's telling you that this reference is required and you should assign it. Now you could say required from this. You could pass in true, which will basically add the component to the game object if it wasn't found. Just to show you the constructors here, so required from this is a required attribute, and if we go here, you see there's an add boolean. Basically, it means that if the reference wasn't found, then just add it. So when you say required from this true, it means that if this reference wasn't found, then add it, as long as the reference isn't abstract. You can also require from children. So say require from children particle systems. So you're saying that you expect somewhere. What happened? Why did it? Okay, I don't know. Okay, the parent was at the top, but now it's okay. So yeah, particle system. Where's particle system? Okay, particles. So couldn't find component in children. So when I add say particle system, so now if I go back to my requirements, I see that it automatically assigned it for me, which is pretty nice. So basically all the requirements, what they do is that they search for the reference. If it wasn't found, they'll try to add it. Okay. You can specify the path. So say from child 1 dash child 2, and so here we're specifying the path, and we're telling it to add the reference if it wasn't found, and we're also telling it to create the child if it wasn't found as well. And why is this repeating? Okay, that's better. So you could create that path if it wasn't found, so it would create child 1 / child 2 for you. So let's see that, for example. Oops. So what is this? Box collider. Let's see. So from child 2, if I take out this tree and I just click on requirements, notice how it automatically created child 1 and 2 for me with the box collider, which is pretty cool. You can also require from parents, just like require from children, but instead it's from the parents. You can also specify the path and the creation. And just like before, you could apply the attributes on properties or fields selectively, or equally the same. Okay, so constraints, randoms, you have some, you can apply rand, which basically gives you a button that gives you random values between what you specify, the range that you specify, so between 10 and 100. This is applicable on floats and integers, on fields and properties as well. Enums, you can you can have an basically a BetterEnum, which basically so here if I left click, I'll get a pop-up, but you'll notice I'm having a lot of values. I get a lot of values, and it's not very user friendly. So what you could do is you go right click and you get a selection window, so you could filter out values and select whatever you want. Now if you've used any of my previous products, you'll notice that this is a brand new selection window, and the previous one looked just heinous actually. This also supports tab, as we will see. You also have EnumMask, which an EnumMask that actually works. Now credits for the implementation of this goes to Bunny83 from Unity Answers. So basically here I have a bunch of permissions that whose values are of the value of 2. So read, write, execute. So I can have this. Pretty much very similar to Unity's layer. Yep. And if you're wondering why we need to have them, why we need to have the flags be of power of 2s, just check out this link. And if you're not familiar with shifting, basically this is just the equivalent of writing them like this, but I think this is easier. Instead of having to memorize power of 2, you could just shift the number 1. So here I'm shifting 1 0 number of times, so it remains 1. And here I'm shifting 1 number of times to the left, so that digit goes like 1 bit to the left, so it becomes a 2. And here I'm shifting 1 2 times, so 1 2, it becomes a 4. This is just binary, basic binary stuff. And one thing to notice, I'll talk about more detail later, is this basic view attribute. Notice I don't have any categories. I don't have like fields, properties, like here. So here I have categories, but here I don't have. This is what basic view does. It just displays one category, and the display options you could also mess with from here. Popups, you have your regular popups. You could pass them hard-coded strings, but this is not very useful. Instead, what you could do is pass in a method that gives you the values. You could probably generate this at runtime or something. So get factors. You can pass in floats and also methods. The methods, they could return a string, int, or float arrays. So here you see the using get factors and returning orc, human, undead, elves. So like that. Count. This is the count of the factor's length, though. So you're gonna get 3, 5, 6, 5, I think. 3, 5, 6. Yeah, this is something you notice I'm not getting I'm only getting 3 values as opposed to 4. This is because the default Unity implementation of Popup doesn't allow you to have duplicate values. So here I have human and elves both have 5 characters, so I only get 5 once and not twice. You can get around with that, but that's not maybe for later videos. And here we go a little bit advanced. So we have a string array property, and we're applying the tags attribute. Basically, the tags, when you apply it on a string, it lets you choose from a pop-up all the tags values that are available in your project. Um, so here we're saying that per item, so for each item apply the tags attribute and unchanged attribute. So for each string we're gonna have these two attributes applied. Now what this does, like I mentioned, it gives you a pop-up of the tags in your project, and then we're logging and that value when it changes. So on change we're doing a log, and if you're wondering about log, it's just a static logging method here. Okay, now the methods that you could pass to unchanged should have one parameter, and there need not be an exact binding, an exact match between the parameter that your method take and the field parameter. There could be a loose binding. So for instance, log takes an object, system object, right, and I'm applying it on a string. Now this is applicable because a string is a system object, so you could do that. The method could be static, instance, private, or public. It doesn't matter. Move on. Here we have selections. So you have a select attribute. You can apply it on system Unity engine objects. It will basically give you a selection window that you can select. So here I could select game objects. You have 3 tabs, so all, children, and parents. So I can select parent, children. Now notice I forgot to disinclude the object itself. And you have all the objects in the scene. Now let me just do that real quick. Selection attribute drawers. Well, I could just say disinclude nice DM value, I guess. Array. And actually no, wait a minute. Game object. So game object, I should exclude it from here. Get children. What is this? Okay, so I can just say disinclude game object. Do I have to cast it to an array? No. Okay, and parents, so I can say disinclude game object. Alright. Moving on. Categories, I'm not going to talk about them now. It take a little bit while to explain. Yeah, I had to do a to array here. Anyway, I'm not going to disinclude it. I had to do a to array because I'm casting to Unity engine array. Let's just leave it. Sequences, okay. So sequences, what you can do, so you get a new, basically the sequence drawer is very similar to previous versions, except it's now a bit more simplified, cleaner, and you could use this seek options to specify options on your sequence. So you can have like an advanced sequence, line numbers, read only, per item remove. This is because by default you get one remove button, which will remove the last sequence, the last element of the sequence, and then whether you want to draw your elements in a GUI box or not. So here this is a read-only with a GUI box. You could also use read-only attribute, read-only, if you don't want a GUI box, so you could just say read-only. Also composition works. Notice here I have a white space and a comment on the list itself, and then I have an advanced, so I'm not specifying per item, which means these attributes will be applied on the sequence itself, not each element. Now, just like read only, instead of saying sec options sec advanced, you could just say advanced. So here we have GUI box, line numbers, per item remove, and here we're applying tags per item, and BetterVector per item. And notice here, this is an interesting situation here. We're not saying per item, we're saying per BetterVector. Now, BetterVector works only if you apply it on a vector 3 or 2 property or field, but here we're applying it on a list of vector 3s. So what's going to happen here is that it's just going to get ignored. Nothing's going to happen. We're going to have a regular list of vector 3s. This is why you don't have to write type checking on your attributes to make sure that you're applying them on the right type. So here we're applying a BetterVector on a type that we shouldn't, but nothing happens and nothing blows up. If we wanted to apply it on each vector, I could just say per item. So here, notice this is the white space, and I'm way down. And what does advanced do? Like advanced, if I check advanced, basically I get a bunch of buttons and controls. I get a new size, shuffle, shift, filter, null, and clear. So if I add a few game objects, I can shuffle them around, which randomly sorts them. I can shift them up or down. I can filter nulls, which removes any null value. I can clear the elements as well, and I can move individual elements up and down, and I also get this nice inspect button, which basically opens up a new instance of an inspector. And what is this saying? Is this from previous? Yeah. So it opens up a new inspector window with your game object to inspect, which is nice. Now this works for any this works for game objects and components as well. So here I have a string, and notice the string have line numbers and a GUI box for the elements and a per removal button, per item button. Okay. And why did I remove this? I probably shouldn't have removed it. Sequence drawer. Probably shouldn't have done that. I should just say true. I should just say true here. Okay. Yeah, it was a design choice. Okay, so BetterVectors. Okay, so you got the removal back. Okay, so BetterVectors, add vectors, so we get our BetterVectors with all our cool stuff. And regular vectors, like I mentioned before, since we didn't define that we want the BetterVector to be applied per item, nothing happens, so we get regular vectors. And this is a read only. Now this is only modifiable from code. You can't modify it from the editor. Some box colliders. You can also inspect them. And so on and so forth. And you get your tags, just like we've seen before in the tags the pop-up example. Yeah. Move on. We have Inline, which is pretty cool. Basically, if you have a Unity engine object, you could mark it up with Inline, and that will draw the editor of that component underneath it. So, for example, say drag and drop this sequences, and here you see the transform component of that game object. So if I drag this cube here, what is this cube? Cube. Is that the cube? Yes, it is. Interesting. Yeah, there's something wrong here. I mean, it should be able to modify the cube's transform. Yeah, I'll look into that actually. I'll write it down. Mid priority. Fix inline drawer. You should be able to modify it. Okay. So box collider, where is this? Oh, yeah. Okay. So you should be able to modify the transform. So okay, moving on. So we have a box collider, and here we're saying hide target and required from this equals true. Now this is a very common combination. So what we're doing is that we're requiring a box collider from this game object, and we're telling it to add the box collider if it wasn't found, and then we're taking that box collider and inlining it and then hiding it. Okay, so you get something like this. So basically there's a hidden box collider attached to this game object, right? And this is how requirements work. If you set it to none, it would try to reassign itself, so it can be none. It's because it's required. So we're requiring a box collider, we're adding it, and then we're hiding it, aligning it and hiding it. And when you align a game object, you can see all of its components drawn. Okay. So yeah, so here we're modifying the transform. Okay. And yeah, there's also a game object inliner, which is just a helper script that you could attach, and then you could inline some game object. Just for convenience. I I think I will stop here and continue, make a part 2. So see you next time.